Good afternoon, everyone present here. My name is Kanaha Palanichami, Assistant Professor. My department is Department of Pharmaceutical Analysis and Chemistry. I am currently working in Sri Shanmugh College of Pharmacy, Salem. So my topic is mass spectroscopy. And what are the mass spectroscopy? Identifying molecular mass of the identifying the compound or unknown compound. So is converted into the this complete process involved in the conversion of sample into gaseous ion with or without fragmentation, which are then characterized by the mass to charge ratio. This is MY/Z ratio and relative abundance. So principle. So, what are the principles involved in the mass spectroscopy? Mass spectroscopy, one of the high technique using to identify the molecular weight or molecular mass of the particular unknown compound, for example, proteins, alkanes, and flavonoids, whatever it is. So, it is the big molecular mass, correct? So, this big molecular just leads to the smaller molecular to find the molecular weight of the particular compound. So, using two gaseous ions and liquid solvent, solid, whatever it is. So this mass spectrometer generate multiple ion from sample. So we are input to the multiple ion in the molecular mass. Finally, the separate to according their mass to ratio and record the relative evidence of each ion type. What are the each ion type class finally detected. So, what are the components present in the mass spectrometer? First one is it is the sample in the where the sample are injected here. Then the samples are going to the source. I mean phase ions. Then ions are converted to ions. So these molecules are break down to fragmentations ions or from mother ions. So mother ions to convert into we are pushing to the ion source. This ionization process complete to a bigger molecule to smaller molecule. That means this means parent ion to fragmentations ion. This ions is going to the analyzer. So various type of analyzer present in a mass spectrometer. This in ion detector is going to the ion detector going to the data system detector. So we are this full source analyzer ion detector is complete in a vacuum pumps. Then also finally is the mass spectrum to find the relative abundance. That these are the inlet system. We are using the solid, liquid, gas. Then ionization means ESI. Then EI, FAB, fast atom bombardment, and MALDI, then PTI. Then this is the detector for this UV, finally similar to the UV detectors, photo multiplier, and Faraday cup detector, and electron multiple detectors. What are the analyzer using in the mass spectroscopy? It is the highly expensive technique or highly technique. So using the quadrophone analyzer, time of flight, ion trap, and FTIZR. Then these are instrumentation of mass spectrometer. This is samples are inject here. This samples is going to the ionization chamber. This big molecular or parenting molecules is converted to the fragmentations ion. This ions is going to the this analyzer. So ion trap analyzer. So type of analyzer it is separating from the depends upon the molecular mass. Okay, this analyzer tube, the positive charge ions, or one type of positive charge ions are collected and another type of molecules are connected one place. So finally existing to collector. Finally existing to the collector, and finally this all reactions are recorded to the mass analyzer and detector. So, what are the inlet system they're using the mass spectrometer? First one is in case of the sample is solid, the lower vapor pressure is directly inserted to the ionization chamber. So, no need to vacuum here. So, directly applied into ionization chamber and volatilization is controlled by heating the probe. So, in case of sample is liquid sample is handled by the injected by the hypodermic needle in a sample inlet and silicon rubber dam. So in case of sample in a gaseous sample, the leak into ionization chamber directly into the mercury manometer. Reminder, the in case the gaseous sample is directly injection into the mercury nanometer. In case liquid sample, we are injecting into the silicon ionization. And the ionization method divided into two categories. First one is gas phase ionization in case gas and vapor. So in case sampler gas and vapor, we are choosing the gas phase ionization. What ionization technique used in a mass spectrometer is a three type. One is electron impact ionization, laser electron impact ionization. Second one is chemical ionization and field ionization. Second one is desorption technique. It leads to the in case sample is liquid or solid, we are choosing the desorption technique. What are the desorption technique in the ionization chamber? It's a field desorption, fast atom bombardment, and laser desorption and molding. Then one is electron impact ionization. The electron impact ionization done by volatilizing a sample directed into the source contained the vacuum system. Okay, then attached to the analyzer. These are directly attached to the analyzer. So in the gas phase of molecules are a bombard beam of electron from eating the filament bias negative voltage compared to the source. In the bias voltage is the commonly mainly is common as minus 70 volts. Then the electron beam eject the ion from gas phase molecule producing radical ion. These are molecular ions. These are ions beam is going to the filament. These ions are the separating the accelerating ions. So first one is slow and second one is moderate accelerating speed. Final speed is going to the analyzer to analyze the spectrum. Then these are electron spray ionization. This is also one type of ionization technique. So electron spray, the samples are spray into the from the needle to the ionization chamber. They're sprayed into the source of chamber from droplets from the spray from the skimmer. And these are chemical ionization between the interaction of sample with large amount of reagent gas. So it's commonly used reagent gas include what are the reagents used? Methane, ammonia, isobutane. So these are chemical ionization. For example, the CH3 low band of electron with CH4 is combined with CH4 5 plus CH3 using the chemicals. So then these are the chemical ions and field absorption. So these are non-volatile sample and thermolabile compounds are only used in a ionization technique. So samples is applied to field of emitter, the solvent allowed to evaporate. So we are adding the sample. The low ion source are present here. The samples are separated from the emitter. Then the focus. It is are focusing in the present in a focus place. Then one analyzer. Fast atom bombardment. It was bombarding. Bombard means oscillating of samples or molecules vacuum with the beam of atoms. So it's typically the xenon and accurate to kilovolt energies. So the sample was typically mixed in a matrix. Then molding. Mold is the high technique of using ionization in a mass spectroscopy and which sample of bombard with laser using laser light. This we are you are using the laser light to separate the sorry using the ionization the or separate the ionization of different molecules using laser in a molding. So these are a sample plate. The sample plate we are using the laser beam here. These samples are separate to the positive ions to negative ion. So we are analyzing the one type of positive or negative sample. This in case of negative ions going to the positive chamber. In case of the positive ions go to the negative chamber. And finally we are going to do mass analyze. Then API method is to ping either one type of analyzer, so ion source. So ionization method. So it's typically done by using similar source of electron spray ionization. But instead of putting voltage spray itself, because using the voltage is different. So placed in a needle that these are liquid. We are using the vacuum or nebulizing gas here. Here this is the heater pressure. So it is a skimmer. So it is a drying gas to high vacuum. So usually it's occur in atmospheric pressure to finally go to high vacuum. Then is go to first one is sample or injector are present in a vacuum or without vacuum. Then finally go to ionization, and finally is converted to analyzer. Means here is the separation of smaller science separation of molecules. The difference upon the mass of the molecule. Okay, we are the type of mass analyzer here. So is the first one. What is the analyzer? So the ion after leaving ion source. The ions are separated according to the mass ratio. So in this area, ions are accelerated both electrostatically and magnetically. So what are the types of mass analyzer? This magnetic sector mass analyzer, double focusing analyzer, quadruple mass analyzers. Quadruple mass is very important for B form, and time flight analyzer, and ion trap analyzer, and cyclo electron analyzer. So what does the quadruple mass analyzer means? The DC bias will catches a charged molecule accurate to move away the center line, the rate being proportional to charge the mass ratio. And these are the ion source. These are the quadruple. These are one, two, four quadruple ions or quadruple mass are present here. If there goes of too far, they will hit metal rods or side of container be absorbed. Then second analyzer is time of flight analyzer. The time of flight analyzer use an electric field to accelerate ions to the same potential and then measured to key they intake from detectors. And ion trap analyzer is the one of the analyzer in the mass spectroscopy. Then ion trap trapped here as sequentially ejector. So this ions are trapped mainly quadruple RF frequency in a space defined as a ring electrode. This is also one type of analyzer. And ion cyclotron analyzer, these are the using to analyze of the. And finally, these are the diagram of the analyzer. So what are the detectors? So finally, molecules are separating from the analyzer. Finally, is going to detector. So using the similar of detectors is converted to UV. This also Faraday. So what are the type of detectors present here, or what are type of choosing detector here? Then first one is Faraday cup and electron multiplier. Then photon multiplier detector and microchannel detector. It's a Faraday cup detector. So it's Faraday cup or cylindrical electrode detector is very simple method. So basic principle is that is the incident ion strike the dynode surface, which emits the electron and into the current which is amplified by the recorder. And electron multiplies. The electron multipliers are probably most common means of detecting ions, especially when positive and negative ions you need to detect at the same instrument. And there are two types of electron multiplier, but they both work essentially by the extending principle of Faraday. This is fold to multiplier. This fold to multiplier ions, this strike dynode, which result in an electron emission. So these are the fold to multiplier tube. These are original proton, rejected electron is a dynode, is going to the anode. So it's the passive ions go to the passive ions going to the cathode, the anode, and active ions go to the cathode. So vacuum system. All mass spectrometer need completely vacuum system allows to ion. So reach detector without colliding with one molecule with another gaseous molecule or atoms, whatever it is. In such collision did occur, and the instrument will suffer from reduced resolution sensitivity. For example, 10 power to 10 minus 2 to 10 power minus 5. So this is the overall instrumentation. First one is sample or injection here, that is going to the ion source, and this ion source is converted into this parent ion is converted to the fragmentation ion. This fragmentation converted to the Morse analyzer. This ions is going to the analyzer, so separating the depend upon the molecular mass of the atom. So it's finally going to the detector, and the signal process here finally recorder. So thank you. Thank you for patient. Thank you so much.